Hello everyone, welcome back to my channel. So in today's video we'll be discussing about the topic dynamic memory allocation. So without further ado, let's start the topic. Now what is this dynamic memory allocation? So from the name itself you can understand that you're doing something dynamically. Now have you heard of the static web pages and dynamic web pages? So what happens in these kind of web pages? In static web pages, if you see every time you load the page, the same content will be there. Nothing changes, right? But in case of dynamic web pages, every time you load the page, a new content appears according to your chat history or according to the suggestions. So everything keeps changing with respect to time. So that is how everything is dynamically changing. Similarly, in memory allocation also, you have two types of memory allocation. One is the static memory allocation and the other one is the dynamic memory allocation. So in this what you're doing is basically you're allocating memory at runtime. And by runtime, I mean the execution time. Okay, so this process of allocating the memory at the execution time is known as dynamic memory allocation. As simple as it. Okay, and then whenever you're performing this dynamic memory allocation, one thing is very important that you have to note. Where are you allocating this memory from? Which part of the memory segment is this memory coming from for allocation in the dynamic memory allocation? So for that, you are basically allocating the memory from this heap, the heap segment. Okay, so when you are performing the static memory allocation, in that case you are allocating the memory from the stack, but in case of dynamic memory allocation, you are actually allocating the memory from heap. Okay, so this is a region of free memory, and from here you will allocate the memory. Okay, in case of dynamic memory allocation. Now let us understand a few basic examples between the static and dynamic memory allocation. So starting with static, so in this what happens is that the memory allocation is taking place at the compile time, whereas in case of dynamic memory allocation it is taking place at the runtime. Now what is the difference between compile time and runtime? Okay, you must be having this doubt right now. So let me clarify this doubt for you. Now compile time is basically the time when your source code, okay, when your source code is converted into machine code. Now by machine code what I mean is that the code is written in the form of zeros and ones, because zeros and ones is the language that is understood by the computer, by the machine. So when your source code or the code that is understandable by the user is converted into the machine code that is in the form of zeros and ones, then it is known as compile time. Okay, that duration of time is known as compile time. And in case of dynamic memory allocation, it is written as runtime. So runtime is basically the time when the execution takes place, and it happens exactly after the compile time. Okay, so it's as simple as that, right? First the compile time takes place where source code is converted into machine code, and then comes the runtime where this code is then being executed, because now the computer is able to understand what is written, right? Because it is converted into machine code already. So that is the difference. Now let us look at the second difference. So in this static memory allocation, you can see that they have mentioned that the memory is allocated from the stack, okay, but in case of dynamic it is allocated from the heap memory segment. Alright, now in case of static, the size must be known at the compile time. Alright, because here it is static, right? Here the memory size cannot change. Let's say I am allocating an array, int array of size 5. Now here this array has got a fixed size 5, and we cannot change the size of this array during the compile time. Okay, so size must be known of that particular variable. That is why it is static. But in case of dynamic, size need not be known at the compile time because it changes at the execution time. That is what all dynamic memory allocation is about. Now in case of static memory allocation, you follow the order of first in last out. So in case of static, in case of the stack memory segment, you must have heard that what is stack, right? If I ask you to take a pile of books and then put it on a table and create a stack of it, so what are you doing? You'll put the first book, then the second book, and then the third book. Okay, so this was the book that you kept first, then came this book, and then this the third one. Okay, that is how you have piled up the books on the table. Now when I ask you to remove the books, what will you do? Will you take the bottom book first, or will you take the upper one? So if you go by the normal convention method, or what normally we do usually is, we take the book from up, we keep it down, then we take the second book, we keep it down, and then we take the third book. So basically what came first will go out last. That is what is the whole theory of stack. That is how the stack memory allocation takes place. So that is what we are following in static allocation. But in case of dynamic allocation, since you are allocating the memory from the heap segment, heap doesn't have any particular order of allocating memory. It is basically a full segment of free memory, and from there, from anywhere you can allocate the memory. So it doesn't really follow a particular order. Now the main question arises, when we have both of these methods, when am I supposed to use static memory allocation and when am I supposed to use dynamic memory allocation? So in that case, you have to make sure about this last point, which says that suppose if you know the size or the required memory that you want, okay, you know that I want this much 12 bytes of memory for my allocation or for the operations that I'm going to perform. So in case of that, you can use your static memory allocation. But suppose you don't know how much memory you will be requiring during the whole program, or how much memory you can extend afterwards. In that case, you can use dynamic memory allocation. Now let us move on to our built-in functions. So in order to perform this dynamic memory allocation, we have got 4 built-in functions, okay, and these 4 built-in functions will help us to perform the allocations. Now let us come on to our first built-in function, that is malloc. Okay, now this built-in function will help us to dynamically allocate the memory. So basically we'll be having 4 built-in functions, and those 4 functions are malloc, calloc, free and realloc. Now in this, except for free, the rest of the 3 are used for memory allocation, and free will be used for memory deallocation. So now let us look into those 4 built-in functions in detail. Starting with our malloc. The term malloc, which you can see over here, basically refers to memory allocation. Okay, so in this what you do is you dynamically allocate a single large block of memory from the heap memory. Let's say this is my heap memory, okay, and from this heap memory I am going to dynamically allocate one single large block of memory, and that single large block of memory can be taken from any part. Let's say this is the large block of memory which is of 12 bytes. Okay, so I'm allocating this memory from the heap memory part. Okay, now that is how the malloc basically functions. From the whole free memory area, you can take any part of the memory and you can take one single block of that particular memory size. Now what happens here is, suppose this is that 12 bytes of memory that is allocated. So during the execution time when this allocation is taking place at the initial stage, malloc will not allocate any particular size to it, any particular memory to it. So in that case, the value will be initially a default garbage value that will be assigned to this memory block. Okay, now let us look at the syntax of it. So here you can see the syntax is mentioned. So in that you can see that first we are taking this is our pointer variable, and in this pointer variable you can see we have got cast type. This cast type over here refers to the type conversion. I will tell about it in detail also. So first you can see we have malloc, and then we have in the brackets as byte size. By byte size I'm trying to tell about the size or the amount of memory that I'm going to allocate over here. Like suppose in the previous example I said 12 bytes of memory is what I want to allocate. So in that particular byte size, I'm going to specify that I want to allocate 12 bytes of memory. Okay, so that will tell me and it will give me an idea of how much memory I want. Alright, and then in this cast type, I'm going to mention the data type. The data type of the value that will be stored in that particular block. Okay, right, let's say this was my 12 bytes of memory. Okay, I have allocated this 12 bytes of memory, but now I want to know what kind of data type I want to store in that 12 bytes of memory. Okay, in that particular single block which is having 12 bytes. So suppose I want to store a data type which is a value which is having an integer data type. So in that case, I will be writing here int, okay, which basically means that in particular block which I am allocating right now, I will be storing values that are of integer data type. Now the question, many people have this question that why is it known as cast type? Are we performing some type of type conversion over here? So yes, we are performing a kind of type conversion also over here. You can see that. Now how are we doing that? Now let's say suppose malloc is like allocating some memory, okay? But right now when malloc is allocating that memory, it doesn't know that what kind of value of which data type the user is going to store in that memory. Okay, now I can store anything. I can store a character data type, I can store a float data type or an integer data type, but malloc doesn't know that. I told malloc to only allocate a memory of 12 bytes, but I haven't mentioned of like which data type I want, which data type I want to store in that particular block of memory. So in that case, what malloc will do is that in this cast type, it will return a void type, okay, a void data type, which basically refers to that malloc is not aware of the data type that is going to be stored in that, so it is returning a void type. And now this void type can be typecasted and converted into that particular data type. Like here, I am allocating the memory for integer data type, so I have mentioned int over there. Suppose I want to allocate for float type of data type, so I'll mention float star over there. Okay, so like that I am doing a type conversion over here from void to integer or to float or to character, like whichever data type I want to store in that block. Alright, now let us look into this example program. So in this, what I'm basically doing, whenever I'm using this built-in functions of malloc, calloc, free or realloc, then I'm supposed to use a header file, and that header file is this one, stdlib.h. okay, this is the header file that you're supposed to use every time you're performing dynamic memory allocation with these 4 built-in functions. Okay, so I've used that header file. Now you can see here that I have declared variables n and I, and I have declared a pointer variable over there. Okay, ptr is my pointer variable. You can have a look at that from the star itself. You can make out that it is a pointer. Alright, so the first thing that I'm going to do over here is I'm going to enter the number of values. Okay, so how many values I want to basically store in that particular block of memory which I'm going to allocate right now. Alright, so let's say the user gave something like 2. Alright, 2 is the value of n. So basically user is saying that I want to enter 2 values in that particular block of memory which I'm going to allocate right now. Okay, those 2 values can be anything, and those 2 values I'll be entering right now. So first user has specified that okay fine, I want 2 values to be entered. So in this, what I'm doing here is in the pointer variable I'm going to allocate that memory. So basically you are allocating memory, but where will you put this memory? You need some space, right? You need some area, you need some location where you can assign that memory. So for that we are using the pointer variable. Pointer variable will provide us with the space where we can allocate that memory. Okay, so here I am going to allocate this memory into this pointer variable. So you can see here n into size of int. Size of int, why am I taking size of int over here? I've used the size of operator. Now you can directly write 4 bytes as, because you know that the size of integer is 4 bytes, right? But what happens is that in different compilers, often the size changes, right? You may have issues with the sizes. So in order to avoid those issues, and of course you cannot remember the size always, right? So it's better to use size of operator. So that's the reason I've used size of operator over here. So what I'm doing here is I am going to multiply n with the size of int. So basically I'm going to multiply n with 4. Okay, 4 is my size of int over here. So it becomes 4 2s are 8. That means 8 bytes is the total memory that I'm going to allocate. And why am I going to allocate 8 bytes of memory? Because in this full 8 bytes of memory, I want to store 2 integer values. Okay, and one integer value will take up 4 bytes of memory. Okay, as simple as that. So here you can see this int star. It indicates that the value that is going to come into this memory location is of integer data type. Alright, so here the user has entered n as 2. That means the user will enter 2 values, and those 2 values are of integer data type. So I'm going to do 2 into 4, that is 8. 8 bytes of memory has been allocated right now. Okay, now the time comes when the user will enter those 2 values. So our n is 2. Okay, now I have going to print the statement enter values. Okay, now the time has come that the user will give 2 values. Now let's say the first value user has entered is 5. Okay, it can be any number. I'm just giving a random number over here. So the user has entered a number 5. Okay, now I'm going to enter this for loop over here. So in this for loop, what this for loop will help me to do is that it will take the values and it will put it at those particular destinations, at the particular locations. Okay, so when we enter the scanf part, what it's doing is that now first let us see the I value. First thing, the I value is 0. Okay, for the first loop, and we enter the loop with an I value 0. Now I'm going to scan the number that the user has entered. That number is 5. Okay, I'm going to scan this number. Now I'm going to store it at this location. You can see here that I have given a location of a pointer. That means I have given a separate pointer variable, and in that pointer variable I'm going to store that value. Okay, I will put the address. So from here I'll get to know the address of it. So let's say the basic address of the pointer that was stored is ptr, that is 1000. So when you were performing this memory allocation, you allocated some memory to your pointer, right? So what was the base address of that memory? What was the very first address of that particular block of memory? Let's say that particular address was 1000. Okay, this is just a random number, it need not be 1000. I'm just assuming it to be 1000 as the base address that was allocated in that particular pointer. Alright, so when I entered over here, okay, what happens is that you can see that I am going to enter the first value in this part where I'm going to do pointer value. Pointer value is 1000 because that is the base address, plus I value. What is I value over here? I value is 0. Okay, 1000 plus 0. Now I'm going to multiply this with 4. Now why am I multiplying this with 4? Because I'm storing a value which is of integer data type, and the size of an integer data type that it stores is 4 bytes, right? So I'm going to multiply with 4. Now this becomes 1000. Now what does this indicate? What does this 1000 mean? You might be confused that I have entered a value 5, but where did this 1000 come from? So for that, it basically means that this value 5 is stored at a location whose address is 1000. Okay, so the value 5 is stored in that particular block of memory which we allocated, and in that block of memory the address of this value 5 is 1000. That is what it means. Okay, now the first I of 0 is done. Now again we will go to the for loop. Now I value gets incremented. From this part you can see I value is incremented. Now I value becomes 1. Okay, I value has become 1. Again we will take one more number. Let's say take 6. Okay, now I want to enter 6 number into this block of memory. So now I'll enter this part. I'll do ptr plus I. So ptr value, that is the base address of the pointer was 1000, right? So I'll do 1000 plus, now I value is 1, right, because it got incremented. So 1 into 4 again, because we are storing integer data type. So now this becomes 1004. Now what does this mean? That my value 6, which is the second value, is being stored at the location where the address is 1004. Okay, so that is how the address has been assigned to the second value also. Now again, when I come to this for loop, now my n value is 2, and 2 is not less than 2, because my I value is 2 and 2 is not less than 2, right? So this becomes false. I and n condition, that is, I'm checking this condition. So you can see that that condition becomes false. So now I'm going to skip that for loop. Alright, so what I got from that, what was the basic output? That I took two values 5 and 6. The address of the first value was 1000, address of the second one was 1004. Okay, so this is what I basically did, and this is that block of memory which I allocated with the help of malloc. Okay, and the size of this block of memory is 8 bytes. Why is it 8 bytes? Because we have two integer data types over here, and one integer data type will take 4 bytes of memory. Alright, so this is what we have been allocated. Now the next thing that I'm going to do is I'm going to print those entered values. Okay, that is 5 and 6 is what I've entered. Now I'm going to print those values, and if it is printed, then that means that the values are properly allocated at the right place. Okay, if it is not printed, then that means there is an error. So again, I will open the for loop, okay, with the same basic procedure. Now here you can see that this is similar to that previous step of scanf. We have ptr plus I, but along with that, you can see that there is an asterisk symbol over here. Now why do we have this asterisk symbol? Because we are dereferencing over there. See, if you put only ptr plus I, you are actually referring to the address. Address means this 1000, 1004, right? You're not actually referring to the values which is stored in that address. So in order to get the values printed on the screen which is stored in that particular address, you have to do dereferencing. So this step is called as dereferencing, where you put an asterisk in front of a pointer again, so that you can actually get the value that was stored at that particular address. Okay, so like suppose at the address 1000, the value stored is 5. So I want to print 5 over here, not 1000, right? So in order to print 5, I'm going to perform dereferencing, and then my final output will be 5 and 6. That is what I gave as input, okay, to the system. This is how a malloc basically works. Now let us move on to a second built-in function, that is calloc. Now calloc basically stands for contiguous memory allocation. Now this is kind of similar to malloc, but there are a few dissimilarities between them. In case of malloc, what we were doing is we were allocating a single block of memory, right? But in case of calloc, we will be allocating multiple blocks of memory. Okay, this is one of the main differences between malloc and calloc, right? So we are dynamically allocating some specified number of blocks of memory of a specified type. That means of any data type. Let's say integer data type, I'm allocating 4 blocks of memory. All 4 blocks of memory belong to integer data type. Okay, so that is how I'm going to use the calloc. Now in this, it will initialize each block with the help of a default value, that is 0. In previous case, that is in case of malloc, it was not initializing with any value, right? That is why we got a default garbage value in the starting. But in this case, it will initialize with a default value of 0. And one more difference which you can find out over here is that it has got 2 parameters or 2 arguments, you can say, compared to malloc. Alright, in malloc you had only one argument or only one parameter, that was your byte size. But here, if you see the syntax, you have got 2 parameters. One is your n, which basically refers to the number of blocks that you want, and the second one is your byte size, that is what will be the size of each block. Okay, if you look at the example which is there on the screen, you can make out that I am using the calloc function and I'm trying to allocate 25 blocks of memory. Okay, I'm allocating 25 different blocks of memory, and each block of memory will have the size of a float data type. So how much size does float take? Float takes up 4 bytes, right? Just like integer. So here we will have 25 different blocks, and each block will be having a size of 4 bytes. Okay, that is what is happening over here. And you can see here float is indicated, which means that whatever allocation I'm doing right now over here is for values which are of float data type. Alright, now I hope you're getting the crux of this. Now if you want to have a look at the example program, it is exactly similar to your malloc program, right? If anyone asks you to write an example program, you can just follow the same procedure of your malloc program. You can see that the same thing is happening over here. You are entering the number of values that you want to enter, and then you will be performing the calloc operation. Then you will enter those values. That is like last time we entered 5 and 6, right? And then here you will be allocating those values at those particular addresses. And after allocating, you will be printing them. So everything is similar to the malloc program. If you have any doubts, just rewind the video and understand the procedure of the malloc program. Everything is similar. It's just that this line here is different. In case of using malloc, we are using calloc over here and performing the memory allocation. So let's say my n value was 2, right? Last time also entered n value as 2, right? So here in case of calloc, what I'm trying to say is that I want 2 blocks of memory, and each block of memory should have the size of an integer. That is, one block should have 4 bytes size. Okay, so that is what I mean by calloc. So here is a table which will help you to understand the differences between two. So we have already discussed about it, right? But still you can do a revision from this. So basically, if somebody asks you to differentiate between malloc and calloc, which is one of the most frequently asked questions, so you can first define that this one stands for memory allocation, this stands for contiguous, and in this you allocate one single large block of memory. In this you allocate some specified number of blocks of memory of some specified size. Okay, then you can mention the syntax of both of them. And here in case of malloc, only one argument is there, that is the byte size, number of bytes. In case of calloc, we have two different arguments, where one mentions the number of blocks that we want, and the other one will tell us about the size. You can see here one is n and the other one is element size. Alright, now this is our third built-in function, that is realloc. By realloc, I mean that I'm going to perform a reallocation of memory. Okay, so I'm going to dynamically reallocate the memory that was already allocated with the help of malloc or calloc. See, suppose in the previous programs you allocate memory with the help of malloc or calloc, but now you feel like you want to reallocate the memory. You want a different memory extension or different size for it. So in that case, you can use the realloc built-in function over here. Also, one more important thing that you need to note is that realloc can be used only when the memory that you previously allocated was done dynamically. Suppose you allocated the memory static in a static manner, right? In that case, realloc cannot be used. If you have dynamically allocated the memory, only then you can reallocate it with the help of realloc. Alright? So as you can see that in this, they have written here that the present values will be there and the new values will be added. Let's say I had some 12 bytes of memory that was already allocated. Now I want some more 4 bytes of memory extension. I want more 4 bytes that I want to add to it. So simply what it will do is that it will add upon more 4 bytes of memory, okay, to the already allocated memory. That is what it happens. So all the present values that were there in those 12 bytes of memory, they will not be deleted, they will not be erased, they will be present over there as it is. It's just that you're appending something, you're adding new values, you're adding a new memory of it. Okay, so that new memory or that new memory space is at 4 bytes. Alright, and suppose you have this 12 bytes of memory, but now you want to say that I want to reallocate it and make it as 3 bytes of memory. Now in that case, you will be losing your data. See, some data was stored in your 12 bytes of memory, right? but now you want to make it 3 bytes. So accordingly, some data will be lost from that 12 bytes and your memory will be adjusted accordingly. Now this is the syntax. You will write the pointer realloc, the pointer that you want to perform the reallocation on, and the new size. That is what you will be mentioning. So here is an example program for realloc. So first, in case of realloc, I'll be allocating the memory using normal malloc or calloc, whichever you want you can use, and then I will reallocate it. So here you can see that I have taken a pointer variable p, and the first thing is that I'm printing that my initial size of array is 4. So in this case, automatically, okay, I have declared the value of n over there, but I'm not going to enter any input over there. I'm not taking any input as of now. You can take the n value input also, but here I have straight away printed that I am trying to allocate a memory for an array which is having a size of 4. That means I want to enter 4 different values in the array. Okay, I want to enter 4 different values in the array, and for this I want to do the memory allocation. Alright, so I'll be using calloc over here. You can see here that in place of n, I have mentioned 4 over there. That means I want 4 blocks of memory. And what is the data type of each block? It is integer data type. Okay, so 4 blocks of memory having 4 bytes each. That is what I'm doing over here. Now this step might be new for you, that is if pointer is equal to null. So what am I doing over here? Now let's say I have n bytes of memory available, but what I'm doing is that I'm trying to allocate n plus 1 bytes of memory. What do I mean by this? That means I'm trying to allocate the memory more than what is already available over there. That means that I will be having a shortage of memory. Okay, there will be insufficient memory for allocation. So when that insufficient memory is there, what happens is that the pointer here will return a null pointer. Okay, it will return a null pointer over there, which means that the amount of memory that you want to allocate is insufficient. Okay, less memory is there. So in that case, memory allocation will not take place. It's not like if you want to allocate 12 bytes, let's say you have 12 bytes of memory available with you. Okay, let's just assume, but you're trying to allocate 13 bytes of memory. So it's not that already 12 bytes of memory will be allocated and 1 byte will be left empty as it is. No, straight away memory allocation will not take place. So in that case, your pointer will return a null pointer. So that is what I'm going to check over here. I will be checking if my pointer is returning a null pointer or not. If it is returning a null pointer, I will print the statement that memory allocation has failed. Okay, the memory allocation couldn't take place due to some reason, and then I will exit from the program. So now if I have sufficient storage, if I have sufficient memory, and if the memory allocation has taken place, then this step will be skipped. Okay, because my pointer is not a null pointer. I have got some memory because memory was available over there. So now let's say I have allocated the memory for I have allocated 4 blocks of memory, each of 4 bytes. Now let us move on to our next step. So the memory allocation is done. Now time to enter the values in it. Okay, so I have 4 blocks of memory and I'm going to enter some values to it. Now again you can see here that I'm scanning the values. Again the procedure that we followed in case of malloc, that how we provided the indexes, that addresses, that we had 1000, then we had 1004, then 1008, right? Similarly we are going to do over here also. Okay, now I'll be going a little faster because we already know the method. So first, when your I was 0, you will enter. Again, let's say your pointer, the basic address of your pointer was 1000. Okay, so P, that is 1000. So what happens over there is that it will become 1000 plus 0 into 4 again. Okay, so that is what is happening. So the first address is 1000. Similarly, the address for the next one will be 1004, then 1008, and then it becomes 1012. So we have got 4 different addresses where we will store those 4 values which we are going to enter. Okay, let's say I entered 1, 2, 3, 4 values. So those 1, 2, 3, 4 values are stored in these 4 addresses which I just mentioned right now. Okay, so this is done. Now what I'm going to do is, now I have already made an array of 4 sides, right, 4 elements, but I want to increase its size. I want to add 3 more elements to it. So how can I do that? For that I have to perform reallocation. Okay, so for that you can see I'm printing this, that I'll be printing that line that I'm going to increase the size of the array by 3 elements. Alright, I'm going to add more 3 elements to this. So what I'm saying here is that I don't want the previous memory to be erased. I don't want it to be deleted. I want those 4 values with me, and along with that I will be adding more 3 values. So here you can see that this is the syntax. We are performing reallocation. P is the pointer on which we are performing reallocation. Now in case of size, you can see here 7 is there, but I am saying here that I want to add 3 elements. Then why is that I mentioned 7 over there? So the main reason behind that is that I have already allocated 4 places, right? I want to add more 3 places to it. Okay, let's say 5, 6, 7, more 3 values I want to add. So how many are the total values right now? 7 is the total value right now. So I want to do a full reallocation of memory, and final memory should be of equal to, like, it should be capable of storing 7 different values in it. So finally I'm going to change the whole memory and make it as 7. Okay, that is equivalent of storing 7 different values in it. So that's the reason I've mentioned 7 over there. And then again, each value is of integer data type. We can get to know from this. Again, we are performing this method where we will check if the memory that we have allocated is sufficient or not, if it is present or not, and if the pointer returns a null pointer, that means we have asked for more memory. That is, memory allocation cannot take place, so it will immediately exit from the program. So now let's say the memory reallocation has taken place. We have added more 3 places to those 4 places. Okay. So we had these 4 places. Now 3 places are empty where we want to enter 3 more integers. So now we are asking the user to input those 3 values that we will be storing over there. Now in this for loop you can see that my I value has started from 4. Before, what we did was I value was starting from 0 and then I was less than whatever the n value which we gave. But here it is starting from 4. Now why is that it is starting from 4? It's because the starting 4 places are already filled with the previous values that we have assigned to it. We want to now fill the remaining 3 which are added after that. So for that, my I value will start from 4 and it will be less than 7, because that is what the total number of blocks will be right now, and that is how I'll be storing. So let me show you the first address. Now let's say the basic address of pointer is again 1000 only, and plus I, the value of I is 4. 4 into the size of integer is 4, so this becomes 1016. Okay, so till here it was 1000, then it was 1004, 1008, 1012. Now it will become 1016 at this place. Okay, at this location it will become 1016. So automatically the next 3 values will be stored after those first 4 values one by one. So that is why we started the I value from 4. Okay, so after taking the locations of 1016, then 1020 and then 1024, all those 3 values will be assigned in these 3 places, and then we will be printing the final array. So in the final array, I'll start from 0, that is from the first value, and will reach up till less than 7, that is all those 7 values should be printed. Okay, again we are performing here the dereferencing part, because I want to print the values that is stored in these addresses. I don't want the address, I want the value stored in that address. So for that I'm performing the dereferencing over here. So that is how your reallocation is done. Now let us come on to our last built-in function, that is free. So till now we used 3 built-in functions, that was malloc, calloc and realloc. And using all these 3 built-in functions, we performed one common operation, That was memory allocation. We were trying to allocate some memory so that we can store something in it. But what about that memory which we have already allocated? Now we have to deallocate that memory. We don't want the memory to be wasted just like that, right? You once allocated and then you can't leave it like that. Like suppose when your phone storage gets full, you try to eliminate that storage, right? You try to clear it so that the memory wastage is reduced, and then you can add something else. So similarly, free here is used for deallocation. That is all the memory which you allocated using this malloc and calloc, all that can be deallocated with the help of free. Okay, all that you can deallocate with the help of this free built-in function, and this will help you to reduce the wastage of memory because you're freeing it, right? And the syntax for this is very simple. You just have to write free and then mention the pointer in the brackets. So if you ask me for an example program on free, it is just the exact program that you write for your malloc or calloc. It's just that after performing everything, after your output has come, the values you entered, the memory allocation is done, the output is ready. After all of that has happened, you can free the pointer from the memory allocation that you did just now, right? You allocated some memory, right? Now you want to erase that memory, you want to free that pointer from that memory so that that memory is not wasted right now. It can be used afterwards for any other purpose. So for that, you will just write this free and you will mention the pointer inside that. Okay, so that was the use of a free built-in function. So that's all for this video on dynamic memory allocation. I hope after watching this video you got a clarity on the concept. If you still have any doubts, you can let me in the comment section below. I'll be replying to all of your comments. So thank you for watching and meet you in my next video.